Hello there. The purpose of this video is to show how to do analysis of non-inverting amplifier, or you can say op-amp. Determine the voltage gain of the circuit. This is about the simplest analysis of an op-amp circuit that we can do. So to start with, the first thing to start with is the breadboard you see right there on the desk. To do this analysis, you need to have two resistors. Two resistors you need to have for this, an op-amp IC. Now the next stuff that you need to have to perform this analysis is an op-amp IC which is 741. Now we'll insert the op-amp IC into the breadboard, fix it in on the breadboard. Now there are two resistors which have to be connected on the breadboard. As you see, these resistors have two legs each. Each resistor has two legs. So we will connect the end of the first leg to pin number 2 and the end of the other leg to ground. Similarly, the end of the first leg of the second resistor to pin number 2 and the end of the other leg to pin number 6, which happens to be the output of the op-amp. Now, since it's gonna be a non-inverting amplifier, I said since it's going to be a non-inverting amplifier, the alternating voltage signal is supposed to be applied to the non-inverting terminal, which is pin number 3. Now, let's try giving you a bit more simpler explanation, ideas, or you say a picture of the circuit that we started in the beginning. So let's recall about the resistors that we connected to do this analysis. The resistors that we connected, the first resistor that we had connected in the beginning was R1, which you see right here in this figure on this breadboard, and also we have RF, which is there on the breadboard. You see it very clearly. And now let's bring the camera onto the values of R1 and RF to let you have a bit much simpler picture of it. So you see there in the camera that the magnitude of R1 that we have taken for this analysis is 1 kilo ohm, RF 2.2 kilo ohm, and you see the formula to calculate the gain right there in the picture. And after calculation, the gain you'll have in your hand will be 3.2. And here goes the connection you see in the video, like you see how the connection is being done. What we are doing right now is that we are connecting the alternating voltage signal to pin number 3, which is our non-inverting terminal. So the connection goes like this. As you see, the connection is about to get done. Now, since you all know very well, since it's an amplifier which has to amplify your signal, some DC source has to be connected to this op-amp. Now I'll show you the connection of DC source and the wires will connect it on the breadboard, and the connection is being done. And while making these connections, we must make sure, I would say we should make sure the connections are tight enough for our analysis to be successful. So the connections are being done, so we connect a positive DC source to pin number 7, of course, and a negative DC source to pin number 4. So like the connection is picked up. So there are total 3 BNCs that we have used in this analysis. The first one used to connect the input to the op-amp, and the second one to view this input signal on the CRO, and the third one, which is our last one, to view the output on the CRO. So these are the connections that you need to make to perform this analysis. And as you saw how these connections we made, and the connections should of course be tight enough for our analysis to be successful. So like the circuit that you see right there on the desk, this is the circuit that you'll get after making all the relevant connections, and now we're all very set to view the output on the CRN, and we'll also get to know a bit about the function generator and also the CRO. Up. So you see how the wire goes and finally gets connected to the function generator. So this is the function generator, you see right there. We use it to generate various signals, and this is the output port that you just saw on the CRO. The wire comes back all the way on the breadboard. The connection you see right there on the breadboard, and it's very clear connection that we have tried to make on the breadboard.
Now we switch on the power supply, and we could clearly see on the CRO there are two waveforms. The top waveform is the input voltage or the input waveform, and the second one, the other one, the below one, is the output waveform.
And like you see the amplification there on the screen, and it's a bit being distorted. It's because of the error we are getting in connection, but still you see the output waveform is amplified, and the amplification is possible because of the DC voltage that we connected to our op-amp and the circuit on the breadboard.
Now we can clearly see the output voltage is larger than the input voltage by gain A, and hence we conclude in the last that both the signal, the input one and the output waveform, is in phase with the output waveform is in phase with the input signal, and hence this experiment is verified for the non-inverting amplifier.
So like I showed you how this analysis is actually performed. Now you can do it yourself. Try it, do it, make it even more successful. And I hope we have done our business with all the with all the honesty, and I wish you good luck. Thank you.